Hi everyone, thanks for watching. In this video we're going to learn about the different types of radiation that can be emitted by unstable nuclei. First of all, remember from the last video that nuclei of atoms can either be stable, which means they just exist, or unstable, which means they decay, break apart, and shoot out smaller particles known as protons and neutrons. This video is going to focus on those unstable nuclei and the types of particles they can emit. That's the technical word for shooting out smaller particles and energy in all kinds of different forms. Those emitted particles and energy that are shot out by the unstable nuclei have a name. It's one you've all heard of before. They're called radiation, which is also why we refer to these unstable atoms as being radioactive. And there's lots of different types of radiation that can be emitted by unstable atoms. Most of them you've heard of before, like X-rays, light that your eye can observe, gamma rays, just a higher energy form of light and X-rays, microwaves as well. There's particles like beta particles, neutrons, alpha particles, and even really weird things called positrons. Luckily, in this class, there's only 3 types of radiation you really have to worry about. Those are gamma rays, alpha particles, and beta particles. What's so special about those guys? They're just a special type of radiation called ionizing radiation. This is nothing more than radiation that has enough energy to actually remove electrons from an atom. And we mean a neighboring atom, a next door atom, turning that atom into an ion, hence the term ionizing radiation. That can still be kind of confusing, so let's actually take a look at it so you can see how the whole thing works. It's pretty simple. Here's an atom, and next door to it is an unstable nucleus. So this guy's decaying and it's shooting off radiation. That radiation is going to affect this neighboring atom. It's going to do something to it. To understand that, let's kind of do what we do when we look at whether an atom is an ion or not. From a couple videos, you might remember you keep score between positives and negatives. And as this atom exists right now, there's 6 positives and 6 negatives, so they balance out. We would call this a neutral atom. However, with this unstable nucleus next door that starts shooting off, say, gamma rays, those gamma rays can actually collide with an electron, removing it. So now, after the radiation hits, we still have 6 protons, but less electrons. If there's 5 electrons, the positive team wins. That makes this a positive ion. We could even do the exact charge. It's going to be +1. So because the radiation ionized this atom, turned it into a +1 ion, it's called ionizing radiation. We'll end the video by going through each type of ionizing radiation and listing out everything you have to know about it for this class. The most obvious part is what is each type of radiation. And the first 2, of course, are particles. That means they're objects with mass, whereas the gamma rays are not objects. They have no mass, technically. They're just a wave. You can think about it as sort of being like light. In a little more detail, the composition of an alpha particle is just 2 protons attached to 2 neutrons. If you could see it, it might look something like this. To really show you, imagine that this nucleus up here, this big giant nucleus, is unstable and it shoots off alpha particles. So you'd see a little cluster of 2 protons and 2 neutrons go flying away. The isotopic notation for an alpha particle would be He24. 2 protons plus 2 neutrons explains the mass of 4. It's a +2 charge because there's only 2 positives. There's no electrons to balance it out. And the symbol we use is the Greek lowercase letter alpha. For beta particles are actually just electrons, which strangely enough can get shot off by an unstable nucleus. Weird, because nuclei don't have electrons, but it still does happen. Just go with it for now. The isotopic notation would be lowercase e for electron, -1, 0. Remember 0 because electrons have no mass. And the symbol would be the Greek lowercase letter beta. Finally, gamma rays are just waves. It's kind of hard to show what those look like, but this kind of oscillating blue and green wave does a pretty good job. So a wave can get shot out by an unstable nucleus as well. Symbol would be the Greek letter gamma with 0, 0 because it's not made of any particles and has no mass. The same gamma would be used for its symbol. And you do have to know all this information about these particles, so make sure you take some time and write it down. That actually concludes this video. Thanks for watching.